All right. Hi, everyone. I'm going to wait just a moment, let a few more folks roll in. All right. I'll start getting started slowly here. So we are in a kind of a block for the hack hours where we are learning more about xarray. It's a foundational package in Python for working with our gridded earth science data. Has a lot of features that allow us to work with very large data sets and working with those data sets in parallel. We're not going to be doing that today, but it also has um, features. Well, I guess you would say it's um, think of it like plugins to access a variety of different data sources. And we talked last week about OPeNDAP. I don't have the video up for that yet. I'm going to re-record the video because if you were there, you'll recall I ran into some throttling issues with one of the OPeNDAP servers that I was getting data from. That is, just so you know, a kind of a common feature for getting data from OPeNDAP servers, thread servers. It's often the case that you will have that they impose a 500 megabyte limit for the amount of data you can get in one chunk. And when you're using xarray, um, it can happen that you are inadvertently grabbing a big chunk of data, too big of a chunk of data at once. Um, and that's what I was running into, and I have yet to debug how to stop from running into that throttling. So I'm going to re-record that and put that back up. Um, if you're working with smaller data sets with OPeNDAP, you're not going to run into that. So smaller data sets, by that I mean making smaller data requests. Um, so I'll show you that again here. So I have a few different tutorials you can go through. This is the one that's having the throttling issues, but you'll see the concept of how you can access data on OPeNDAP servers. So today we're going to learn about accessing Argo data. And we are going to use the argopy Python package. And um, we'll be getting the data from an ERDDAP server. It's going to happen in the background. You're not going to be aware of that. Next week, I will talk more explicitly about how to get data from ERDDAP servers. But today it's happening in the background. All right. So let me give you this. And here we go, chat, chat, chat. Doot. Uh, yeah, Rich, I was trying to open up a whole lot of data all at once and show how to create a really cool big data cube. But it worked last year. I don't know what happened. It's not working this year. Yeah, so I was trying not to do time equals one. All right, so there's the link to our web page, and I'm going here to accessing and visualizing Argo data. So we're going to be doing this tutorial right here, argopy. Okay, so let's first talk a little bit about what is Argo data. Um, so Argo data are these floats. They're all over the world, floating in the ocean, mainly in the deep water, because they go down to 1,000 meters. And these buoys, so it looks kind of like this. So they're all there, floating all over the ocean, and they will descend down to, well, they're going to drift here, and then they'll descend down to 1,000 meters, 2,000 meters, something like that. And then they'll start ascending and start recording data. Sometimes they also record data on the descending. You'll be able to tell the difference if it's recording on the ascending or descending. But in any case, it's recording data as it's going up. And then it gets up to the surface and it transmits that data. And then it starts another cycle. Argo data. So there's kind of two kinds of buoys. There's the Argo buoys, and they'll be collecting, things like temperature, salinity, these physical properties. And today we're going to work with the BioArgo, and those record some other variables related to biological things in the water. So we'll see that in just a moment. Um, some things to know about when you're thinking about working with Argo data. So each of the buoys has a buoy number, a platform number. It's called a platform. So it's the platform number. And so you have one platform, one buoy, and that buoy is doing a lot of these cycles over time. So lots of those. Each cycle has a number. So the data are organized as the platform number and the cycle number. Each platform number will have many different cycles. It will report the latitude and longitude as it's collecting the data and the time. It will also record the depth expressed as pressure. Okay. So I put a little link here. You can, if you've never worked with this data, you can, look at a little video on that. These data are really great, and it's an incredible source of in situ data for the ocean. And another amazing thing about it is they have put so much work in making this data open and easy to access. There's a package called argopy. Oh, I should say one more thing about how this data is openly accessible. So there are lots of buoys out there, lots of different groups that run these buoys, and they assemble all that Argo data into this assembly center. And then they also take that data, which are the raw, I don't know how, I honestly am, I'm not really sure what the raw data that's being transmitted looks like. But once it gets here, it's a series of net CDFs. So those would be called the raw data. And then they take that and they'll put that, you can access that with the ERDDAP server, and it's kind of standardized a bit, makes it easier to work with. You can research that. Okay, so let's take a look at this package. Actually, I'm going to go to the documentation here. Okay. So, so this package makes it really easy to access the data. And what we're going to be doing today, because we're in a block about xarray, I'm going to show you how to get that data and pull that into xarray. And then we're going to work with the xarray data set. However, if you are working a lot with Argo data, be aware that the Argo package itself will do a lot of the things that I am showing. I'm more interested in just, hey, I want to get it into xarray and I'll take it from there because I know how to work with xarray. However, I just want to show you that they've got a great cheat sheet here and lots of different functionalities for working with this. Like I said, we're going to be getting the data, but they also have things like, oh, what do they have? Um, like, plotting things, how to visualize it, how to grab, a certain platform number in a certain cycle. So they have all these utilities in there. We're not going to use that. We're just going to grab the data and get it into xarray. Okay, let's go back here. Okay, so we are back here, and I'm going to go ahead and open this up in Colab. As I've been saying, we also have a Jupyter Hub. Can reach out to me to get access to that. Everything's installed there. It's like our playground for learning, open to anyone at NOAA. So just reach out to me. Yeah. But let's click on that Colab link. And let's see, we've got that. So first thing that we need to do is we need to install the packages that aren't going to come pre-installed on Colab. That's going to be argopy and cartopy, which is going to help us make pretty maps. So let's go ahead and install that. Yeah, do that. Do, do, do. Okay, I'm gonna try to watch the chat here. Yeah, feel free. We're a pretty small group, so feel free to throw a question in the chat. And if I don't see it or respond, it means my computer didn't ping me. So just unmute and say something.
So
Okay.
does the Jupyter Lab have the package already there?
It does not. You'll need to do the pip
Okay.
install. It does have cartopy, but it doesn't have argopy.
Okay.
So you can run it with the cartopy. It won't scream. I mean, it'll say it's already installed. All right. So getting some data. So how does argopy do this? So um, you you create this fetcher object, and you're saying what is the data you want to get, and what is the region that you're looking at. So the region is going to be did I have it? Yeah. So the region is your longitude minimum, longitude maximum, latitude minimum, latitude max. So you're saying a spatial region. Then you'll say the depth ranges and then the time minimum and time maximum. This region specification is going to determine how much data it actually goes out there and gets. So remember, you're hitting a data server, and that data server probably has a limit of how much data you are going to be getting. So you don't want to go and get the entire data set all at once. So we're going to specify our space range and then specify our date range. Okay, so let's start out by looking at what variables are um, accessible to us. And yeah, okay. So, so I say the region that I'm looking at, and I'm going to use the Argo data fetcher. This is a package within argopy. The first thing is the data set. And I'm going to be getting bioargo data. That's called BGC. Then the source, I'm going to be getting ERDDAP. And this is processed data. So it's not the raw data. You can read in the documentation about what that processing is. It's things like there'll be some quality control. There'll be standardizing the um, depth information. Um, yeah. So you send the source, And so this is really standard. It's very standard to use the ERDDAP data if it's like a science application. And then you're going to pass it the region information, which is this up here. And what I'm going to do here is I'm not going to specify the variables. I just want to see what variables are available in this region in that time period. So let's go ahead and run this. So it's going out there, it's going out to the server, it's getting this information, and boom, comes back. Tells us some useful things. It tells us there's that spatial domain, just checking, making sure it's right. It tells us which ERDDAP server it went to. This is the French one. And here's the thing, it tells us these parameters that are available for us in that region in that time frame.
Eli,
Yeah, go ahead.
the import is for me like the import Argo data fetcher is in the cell below, and so um it it failed that cell just because the import is below it.
Oh, crud. Yeah, okay. Yeah, yeah, thanks. So grab that, put that in here. I was moving things around a little bit. Why did that work for me? That's
I
really
think you
strange.
didn't restart the kernel, maybe.
Yeah, probably not. Yep. Okay. Okay. So what are these parameters? These BioArgo have a fluorescence sensor, and this is a fluorescence parameter, backscattering at 700. That's the spectrum, and then it has a chlorophyll A estimate. So this is a processed variable from that backscattering. Um, these are some other things from that, your downwelling, some irradiance. What else is over here? Oh, interesting. Huh. This is dissolved oxygen. I said interesting because not all buoys and regions have that. Not all they don't always have that sensor on the buoy. So that's interesting. Nitrate, again, that's kind of interesting. It's not always on them. And we also have pH, and then that this one here, PRES, that's going to be our depth. This is going to be salinity and temperature. These three are ones you basically will always have. And then these other ones are things like this one here, chlorophyll, that one's really common and that one's really common. Some of these other ones are not so common, and dissolved oxygen and nitrate are really not so common. So if you're interested in those, you'll have less data. Okay, so now what we want to do is we want to create a fetcher where we specify what parameters we actually need. The reason is, again, we're hitting a server. We don't want to ask for more data than we need. We don't want to be running up against whatever limits they have on their end. So we're going to run that. So now what it's doing is creating this fetcher object for us that's going to go hit the ERDDAP server and give us the data that we need. So it's all set up for us. And now we can use the argopy to xarray function to go and actually grab the data and put it into xarray. Okay, it's going to take a moment. Thanks, John. Yes, lots of great information on the BGC Argo Buoys. This is such an incredible data set. I am so impressed with this community and the way they've made it so easy to access this data. Okay, so here we go. Let's check that out. So now we have an X-ray data set. Perfect. What does this look like? It has number of points, got 9,000 points here. and then latitude, longitude, time, coordinates. Let's look at the data variables that we have. Let's see, I wish this were a little bigger. Okay. So we've got our chlorophyll, we'll have our error, quality control. This is, as I said, the buoy number. So I said buoy, so it'll have the platform number, that's the buoy number, and then the cycle number, which cycle it's on. So there's your platform, there's your cycle. Direction is going to be ascending or descending. I think in this data set, it's only ascending. Actually, so what that means is it was only collecting data as it was going up. Position quality control, here's your depth. And so these buoys, well, I told it only to go down to 1,000 meters. Some of the data will go lower than that, but in the data request, I said only data down to 1,000 meters. So that's why it's cutting off there. And then it's coming up to the surface or very close to the surface. Then we have our temperature and our salinity. Okay, so I'm going to make this into a data frame here. So let's just add this df.head. So you can check that out. So now I've taken that xarray. I'm not going to use this right away, but I will use this later. But if you want to be working in a data frame, you can do that quite easily. You take that xarray data set and you say to data frame, and now I've got things like this. So here's some of my variables, platform numbers. It's in a data frame with 9,000 rows. Okay, so let's do some interesting things. First off, let's plot the data. So what we're going to do is I am going to take my box from my region, and I'm going to use cartopy and matplotlib to plot this. I'm going to tell it, hey, take that box and make it a little bigger. I'm going to add some coastlines, add some features, and then I'm going to do a scatter plot, and I'm going to plot the longitude values from my xarray dataset, the latitude, and then I'm going to color the points with the platform number. So let's go ahead and do that. And we can see what I've got here. So here I am, as I said, I was looking at North Atlantic, and these are all the buoys. I've colored them differently. So you can see there's quite a few buoys in this. It's a 1 month period in 2024. You can see that some of the points, they're separated. I didn't color the cycle numbers differently. My guess is this is the same buoy, but different cycles. So it's done one cycle, then it's drifted a little, and it's done another cycle. So see that going on here. Okay, so that's our data. Now let's take a look at one of these cycles. So what I'm going to do is I'm going to take that data set, that xarray data set, and I'm going to get the unique platform numbers. So here are all the platform numbers, and I'm going to get one of them because I just want to plot one cycle. So I'm just picking the first one of the platforms. So that's the buoy that I'm going to look at. And then I need to do the same thing for the cycles. So I need to get the cycles for that platform. So these are all the cycles associated with that buoy in my data set. Get the unique ones and take the first one. I'm just doing this to I just want to plot any cycle. I don't really care with which one at this point. So this is just a way to get one of them. The next part is I'm getting the profile, and I'm going to get all the points in my xarray data set where the platform number is equal to the one I selected and the cycle number is equal to the cycle I selected. Um, and now that I have a single profile, a single like going, actually it's all ascending, so it's all going upward. I now am going to get the chlorophyll and the pressure, and then I'm going to get some of the this says QC, but it's pros. Oh, this is QC. Yeah, so this is the quality control variable there. And then I get the depth and okay, just a little bit of like decoration here. So let's go ahead and plot this. Take a look at this. Okay, so I'm doing this scatter plot of the chlorophyll against the depth. And here we go. Okay. So these are points where it said the quality control for the chlorophyll was not great. And these are the ones they say it's good quality. This is the chlorophyll measurement, and this is the log 10 of the depth. So this is about 100 meters. And this shows something that we often see in these open ocean um, is that the peak chlorophyll can occur at these. It doesn't occur at the surface, it occurs lower down. So here the peak chlorophyll is happening around 100 meters. All right. So now we have that. And let's say we wanted to start processing this data into average chlorophyll at particular depths. So let's say I wanted to get the average chlorophyll at this depth, that depth, that depth, that depth. So how would we go about that? That sort of thing. Um, so this shows a example of creating a couple functions to do that. Here I created a function that will take a profile and it takes the depth, it takes the information on the variable, it takes the depth range, and then it returns the average. So create a little function to do that for me. And, or I should say, I mean, honestly, uh, nowadays I told a chatbot exactly what I wanted it to do, and it made it, and I checked it. And then the next one is I take a create another function that's going to take a um, it's going to use that average function, and now it's going to take a single um, profile. So it's going to take a buoy and a cycle, and now give me all those depth fins. And it's going to give me one row. So now I've got that. And then I'm going to next, I'm going to take those functions and I'm going to apply them, or I'm going to take that summarize profile bin function and now I'm going to apply it. And what I'm going to do here is I'm going to use group by. And so what it's doing is it's grouping by the buoy, platform number, and the cycle. That's now a group. And then for that group, it's going to apply this summarize profile function and give me a row. So it's going to go through all the data and all the groups and give me the average chlorophyll at the depth bins. So this is a bit of data munging. There we go. And now, oh, that was it. It did that. And now we can see this. So now I have processed all those. And actually, let's see how many. I think this is what I want. Please tell me this is what I want. Yes, okay. So I have 41 of these groups. So 41 samples of ascending. I don't know how many different buoys those are. Um, yeah, some number of buoys. All right. So that kind of walks through accessing um, some bioargo data and then processing that and getting that into X-ray. And it does, I mean the code's a little like, yeah, you have to write those functions, but it's pretty straightforward to, apply the whatever you want to be doing. Here, I want it to be grouping the data, but whatever however you want to be processing the data. It's once you get familiar with the structure of it, um, I've found it's not that hard. Okay. So I'm going to stop there for a moment, see if there are questions before I show you the next part.
Eli, was this based on a Argo like notebook tutorial, or you came up with this all by yourself? Well, you and your assistant came up with this by yourself?
Um, yeah, no, this is an example I came up with, and this is supporting some research that I'm doing that is using bioargo data.
Yeah, super cool.
Yeah, and but I developed this for the tutorial. I wanted to develop it to show using argopy data with xarray rather than using all the argopy functions, showing how once you start to learn xarray and how to work with it, you can get a variety of different data into an xarray data set, and then from there, what you've learned about working with xarray you can now apply to a new type of data.
Yeah. Yeah, it's
So
nice.
yeah, go ahead.
Oh, it's nice to see all these little examples of group buys and where and all
Yeah.
that stuff. Yeah.
Okay, so now I want to walk you through um, how I took those ideas to get the data set that I needed. Okay, so what I was doing is I'm doing a machine learning project where I'm using bioargo data to train against remote sensing data. I'm creating a product. I think, yeah, I presented this earlier. I'm creating a three-dimensional chlorophyll product. So getting chlorophyll at depth, at below the surface. So lat long depth. So I'm creating that. And in order to train my model, I needed a lot of in situ data. So what I wanted to do, what I did, was I queried all the bioargo data in my time period of interest, which was from February 2024 to the present. This plot shows all the bioargo data available to me in that period. This is, as it worked out, um, was almost 16,000 profiles. So a lot of buoys, a lot of these cycles. But you've just seen how to do it for one region. And logically, what I needed to do was then run through the entire globe and all the time periods. So, processing the whole globe took about 4 hours, so it didn't really take all that long. The basic thing that I needed to do was um, I wrote a function that goes and gets the like that data frame that I just showed for one region. So I wrote a function that does that. And I what I needed to do was specify a whole bunch of regions. So I needed to break the globe up into these regions. And the reason for that is, remember, I'm hitting an ERDDAP server, and it's going to throttle me if I don't break my request up into smaller subsets. Okay, so so I broke it up into region and then in also month. So I did monthly, and then I took a lat long region of the globe. So yes, yes, it's hairy. Thank God for chatbots. Um, so um, if you haven't worked a lot with chatbot for creating code like this, so the approach that I'm when I'm using a chatbot to help me code is I'm starting with what I showed you in the tutorial. So I'm trying to get the logic of just getting one region. So I've worked out on a piece of paper what I think the project's going to look like. So I know I need to like be able to get data for a region and a time period. And then I'm going to need to sort out the functions that get me to that data frame. And then I know I'm going to be piecing together data frames. So first I get that part working, and I'll be talking with the chat bot about how I want to approach this. And I'm probably iterating a few times until I get that solid. And then once I have that solid, I can show the chat bot those functions and say, okay, now I want you to write me the code that takes this and applies it to the whole globe. And I'll describe how I want the regions of the globe broken up. So I'm giving it very precise instructions, but I personally am not writing the raw code anymore. I did that for decades. I've done enough of that. The chatbot's a lot better. But I do need to like be able to give it very precise instructions about how I'm approaching things and what I want to do. Um, and then I'll tell it right. Usually it does this by default, but sometimes I'll ask it to add more comments so I can like skim and check its logic. So once I have that, then oh, it looks like this only takes 8 seconds. Okay, let's go ahead and run that. So I've told it to create that for me. And now what I'm going to do is I'm going to test this. So I'm going to give it one region, and I'm going to test that how that function's working. I haven't actually tested this part for you today, so fingers crossed. Yeah, there we go. Haha, 9 seconds. Perfect. So I know that function's working. It's giving me what I want, which is these are these these average chlorophyll within these depths. I also impose some constraints around like how many points I would need, what the data quality was. So that was all in that big function. Um, you can see, there we go. Got it. All right. So now I know that basic function's working. And I added this script false so that I didn't accidentally run this because it would take a really long time. But basically what this is doing is it's going to run through all the months in my period, which is March 2024 to the present. It's going to run through all those. Um, what it's going to do is I'm going to output to Parquet, and I'm going to output each month and region to Parquet, and then at the end I'm going to assemble all those Parquet files together. Um, Parquet is a very efficient way to store things, and it's also really great for creating cloud native tables. So that's why I'm working in Parquet. What else to say? I also was outputting as I went along because if anything crashed, I didn't want to have to start from scratch because this does take 4 hours. What else was I doing? Okay, here you can see I chopped the globe up into these 45-degree bands, latitude and longitude. So that's what I'm doing there. Tell it how I want my columns to be ordered. And that's it. I set it going, and 4 hours later, it was done.
Hey, Eli,
Yep.
if you had like used a Dask cluster to try to do it in parallel, would they have like rate limited you or like shut you down, or would you think that would work if you did all these things, all these different little pieces in parallel, or would the server crash or something?
I think it would be okay. I think I could have done that.
Okay.
Yeah. Um, I did do Dask clusters I used Dask Gateway
Yeah.
for when I did the matchups to the remote sensing data because that took um that would have taken 4 weeks if I hadn't done that. And I used Dask Gateway. So if you haven't ever heard of Dask Gateway, okay, so there's Dask. And Dask, actually, let me talk a little bit about Dask and what's happening with this too. So in previous weeks, I talked about how xarray will use Dask in the background and it will process, let's say you're doing a mean for an absolutely massive data set and that data set's in the cloud. Well, um, if the data are chunked, xarray will know about that and it will use Dask and it will go and calculate this mean working chunk by chunk, so that it doesn't have to try to load a, say, terabyte of data into memory. And it's important thing, I forgot to show you this, but let's go back up here. Okay, let's take a look at this. And if we look at these data variables, let's just look at the chlorophyll here. Okay. So what you should note about this is it just says array, and it actually shows the numbers there. So this is not lazy loaded. It actually loaded that data into memory. This data is on a thread server. It's not cloud based, and it's going to load that data into memory. So that's another thing we need to be careful about when I'm doing this, that I want to make sure I'm running this on a machine that's going to be large enough to handle the data. So I want to grab chunks of things that are going to be able to load into memory. Just something to be aware of. And I think that that's a general thing when you're working with xarray and you're working with really large data to be kind of skimming this and looking if it says Dask array. If it doesn't say Dask array, that means when you try to do something, plot, take a mean, It's going to load that data into memory. Or it may have already loaded that. It may, like in this case, it actually already loaded that data into memory. Okay. Um, all right. So for this, I'm not it because of that, I wouldn't be using Dask in the background to go chunk by chunk. However, what I can do is I could do Dask Gateway. And what Dask Gateway allows me to do is spin up a whole bunch of virtual machines. And then I can sorry, oh my God, scrolling too fast here. And I could give it this loop and it would figure out how to do this loop across these different virtual machines. All right. So I saved this to Parquet and then I merged them all together. Part of the reason I didn't go into trying to use like multiple virtual machines or setting up a cluster for this particular case is that I did run through some test cycles and I could see, oh, and I could compute in the back of the envelope how fast it was going to get done. And it was going to get done in 4 hours. So I was like, yeah, that's fine. So it wasn't worth it to do the extra work to try to run this in parallel on different virtual machines. I
It's
did
just,
learn, yeah, go ahead.
I was just going to say, just as a humorous side note, Scott Henderson gave a presentation where he showed somebody who had a rock on their space bar to keep their notebook from dying while they ran along.
Yeah, yeah. Okay, so one thing I learned through this that I didn't really expect is that um, I kept changing my mind how I was going to summarize the profile data. And so it didn't actually just take 4 hours. It took um, a lot longer because I'd run it 4 hours and I'd look at it and be like, I don't know, I don't want to summarize the data like that. And I changed my mind. I kept changing my mind. And I think that that was one of my lessons learned is that it was actually would have been better. And this is what I eventually did is I got the data and I got those xarray data sets and I saved those as netcdfs locally. And it was really big. Those files were big, but then it was a lot faster so I wasn't getting the raw data. I was processing the data, but I saved that data with all the platforms and the cycles. I saved that locally and then I ran my summary. I could run my summaries very quickly because and then I could make different decisions about things like how many data points do I have to have within a depth range? What is the quality control I want to impose? All those kinds of things. I kept changing my mind. All right. Okay, so that's the end of that. I'm not going to go through it, but I will show you this file here walks through how I went and got um how I did the matchups. So it talked about the workflow to um process. In this case, I'm working with PACE hyperspectral data. How did I do those matchups with the bio um, Argo data and some of the tricks that I needed to use as I was processing that. So there are a few key tricks here. One is I was opening these NetCDFs, cloud-based NetCDFs using xarray, and it was important to be specify chunks so that it would make sure I invoked Dask. Otherwise, it was trying to, when I was doing matchups to the BioArgo data, it was trying to load in these huge NetCDFs from the PACE remote sensing data. So that was one thing. Um, Secondly, I use something that's called vectorized indexing. This is something you can use when you're trying to do really large matchups. So I had many, many thousands of points, and I'm trying to do a matchup. If you tried to do that with a for loop, said, hey, take these 2 points, get that point, find the remote sensing data in this NetCDF that matches those, next go to the next point, that would take a really long time. This talks about how you do vectorized indexing. And then the second thing that I used was processing files in batches, which was helping prevent the um, memory from exploding due to some memory leaks. Okay, I am going to stop there for today. And next week, we're going to be talking about accessing ERDDAP servers with xarray. ERDDAP servers are really great, and they have some features maybe you haven't seen before of how you can, if the ERDDAP server is using GridApp, you can access the entire data set, all the years, all the variables, everything, and get it in one lazy loaded um, xarray object. So I'll cover that next week. Then I'm going to switch into starting to talk about accessing modeled ocean data. I'll show some examples. This is more working with ERDDAP and OPeNDAP. I think that's what I'm going to do. I may do access some European data that's in XAR. I haven't entirely decided which to. And then for the rest of May, we're going to have 3 guest lectures. Rich Signell, who's here on the call, will be talking to us about VirtualizR. And then we're going to have a talk on using XPatcher for when you're doing model fitting and you're working with larger than memory data. And then we'll finish off the series with Matt Fitcher, who's going to be talking about using QGIS within Jupyter Lab. All right. That is it for today.
Cool. Thanks, Eli.
Yeah. And sorry to the R users. I think there are also packages for working with BioArgo, but working with Argo data in R. I should have looked that up. Okay, everyone, have a great weekend.